Hi, Sean.
Hey, how's it going?
Good. Sorry about that.
That's all right.
I had a very strange day. I had a very late impromptu 3-hour session, and I guess it fried my brain. I completely spaced out our session. So,
That's fine. We're gonna be on my math lab doing homework.
oh, wonderful. That's what my last 3-hour session was on one of these. Boy, I tell you what, that's what happened to me. I was sitting here thinking about the implications of this new method of teaching that seems to be, I've run into this with like 6 students now, where it's no longer multiple choice online tests, which means you have to get the answer precisely right.
Yep.
A new chapter, huh?
Yep.
What are we doing here? More integration? Is this volumes of solids of revolution yet?
I don't know. I actually haven't had a chance to look at it yet.
Okay. Oh, integration by parts. Okay, cool. Integration by parts is probably the toughest thing you've learned yet. Let's go over it. There's no convenient product rule when you're doing integration. There's a real convenient rule when you're doing differentiation. But if I'm taking the integral of the product of two things, let's say the integral of u dv, if you start with the rule for the product rule in differentiation and work backwards, you get the following. Now, at first glance, this might not mean much to you, but this is the underlying theorem for all problems involving integration by parts. You'll notice that what we have to integrate here is 9x, which is a polynomial function, times e to the 7x, which is an exponential function. So substitution isn't going to help because the inside derivative is 7 and we've got this x over here. So whenever you see the product of two different type functions, think integration by parts. Now, what even does that mean? Well, the best way to explain it is to go through this problem as to how to do it. Now, let me write something else over here. You may have seen something similar to this. Might have said log poet or lipit. Lipit stands for logs. I stands for inverse trig. P stands for polynomial. E stands for exponential. T stands for trig. I'm going to go through the methodology with you. Try to memorize the methodology and forget the understanding of it for a moment. I need to figure out what to let u equal and what to let dv equal. So here's the methodology. I'm going to let u equal whatever the priority is determined by lipit. If there's a logarithm, I'm going to let u equal that logarithm first. Okay, what can we let u equal here? Well, we got a choice of 9x or e to the 7x. Polynomial comes ahead of exponential, so I'm going to let u equal 9x. So what is dv? dv is everything else. E to the 7x dx. Now what I'm going to do is differentiate the left column and integrate the right column. Because in order to solve this, I need u, I need v, I need to know what du is. So to solve for du, I have to differentiate the left. So du dx is equal to 9, and that makes du equal to 9 dx. I also need to know what v is, because right now I don't know what v is, I only know what dv is. So to figure out what v is, I have to integrate the right. Well, if dv equals e to the 7x dx, and I integrate both sides, I get v equals e to the 7x divided by 7. So now I know what u is, I know what v is, and I know what du is. So I can do the translation. So if we go up here, and we go to write it out, u is 9x, v is this, minus the integral of e to the 7x over 7 times du, which is 9 dx. Well, at first glance, it might not appear that we've accomplished much, because we started with an integral that we didn't know how to integrate, and we still have an integral. The difference is that we now have an integral that we know how to integrate. I can integrate that. So after I integrate this, I've solved my problem.
Is there no integral sign before the first set, 9x?
There is none. There is none. This, I tell you what, this is something you're going to want to watch the recording on.
Okay.
I'm just telling you, because this is very different. We're not used to substituting for a dv. We're used to substituting for the u part of it, but not the dv part of it. So let's continue here, and one of the problems I have with this is that I always run out of room. I'm going to erase everything right here. I want to leave this lipid up because I'm going to leave that there for additional problems. Because the very first thing you have to determine is what to let u equal. Once you figure out what to let u equal, then dv is everything else. So it's simple then. So this lipid is very valuable in determining what to let u equal. But let's go back and finish this problem. So we now have 9/7 x e to the 7x minus, well, what's the integral of this? This 9/7 I can take outside the integral, first of all. And now we have the integral of e to the 7x, which is what?
E to 7x over 7.
Correct. Plus c. So there's our answer. We've integrated it. Now let's see if we can simplify it here. We have 9/7 x e to the 7x minus, I'm not going to multiply that because you want to factor stuff out if you can. So let's leave it exactly as we're looking. And let's factor out a 9/7 e to the 7x. So let's rewrite this. in general, with calculus, you want to factor stuff out. So we can factor out this. And what are we left with? X minus 1/7. So this is the answer.
Plus C, right?
Plus C, correct. Thank you. I was sitting there spending the last hour trying to figure out how to solve the problem of inputting the answer, because so often with this new software, you know how to do it, but getting the answer in is very tough.
Mm-hmm.
So let's try this. Hold on. Make sure I can see it. Now in this particular case, they may accept an unfactored answer, or they may not accept the factored answer. I don't know. We'll try it both ways.
Nope.
Why is that red?
It's always like that until you finish it.
All right.
Are you pulling out e to the 7th x or just e to the x?
No, just like this. Whoops. That's what I want there. In other words, that should match this answer, plus C.
But see, in your answer that you wrote, you put 9/7 e to the 7th x.
Yeah. I do want the 7 in there. See, what I don't like about this software is that it forces you to figure out their game as to how to put in the answer exactly the same. Is that the same?
Yep.
All right. This software here is actually superior to the software I just worked with, which was called mymathtest.com or something like that. Well, what's the integral of natural log of 5x?
You just beat me on this one.
Me too, actually. I have to look. I have to look it up. No, it's not what you think it is. It's different. This is a tough one. Gosh, this is so tough that it's not even in my book. Wow, I'm going to have to go to a table on this one. What is the integral of log x? Hold on. All right. Wow. I can't believe this is the first time I've ever run into this, but it is. If you go to a log table or an integration table, which has 99 entries in it, they will tell you this integral. It's equal. And truly, in 4 years of tutoring calculus, this is the first time I've ever dealt with this. Okay, so what does that mean? So the integral of natural log of 5x is going to be 5x times minus 1 plus the natural log of 5x plus c. Well, not plus c because this is a proper integral. So evaluated from 1 to 4. Okay. So let's go through the evaluation of this. Let me not erase that for the moment.
So first we just plug in 4.
Okay, so we got 20 times minus 1 plus the natural log of 20. That's the first part. Minus what?
The same thing, just with 1.
So it'd be 5 times minus 1 plus the natural log of 5. Okay. So working from the inside out, let's have some numbers here. Find that number, multiply it by 20. And what do I have?
Alright, so the left side, if I did it right, is 39.9146.
9146. Now, I can see a potential problem coming already. Do not round until the final answer. So, do you have a couple more decimal places?
Yeah. 4548.
4548. Okay. And how about the second part? The 5 times, that was, you did multiply that by 20, right?
Mm-hmm.
Okay. And how about the minus 1 plus natural log of 5 multiplied by 5?
3.047188.956.
Okay, I think 6 will guarantee us accuracy. So now, can you take this first number minus this second number?
Mm-hmm. 4 decimal places. Okay, so 36.8675.
You rounded off already?
Yes.
That should be it. Oh, man. I never thought I'd say this, but this is not a good step in education. Wow, use integration by parts to integrate. Okay, let's go back and redo this. See, what I looked up in my integration table was the integral of the log of u. Well, this isn't the log of u. This is the log of 5x. Cool. Okay. I wish they'd have said use integration by parts in the start. That would have saved you a lot more time. This is the difficulty of integration. So based on Lipit, what should I let u be?
Logs.
Natural log of 5x. What is dv?
dx.
Remember, my master formula is when I want to take the log or the integral of u dv, it's equal to u times v minus the integral of voodoo, v du. So let's leave that there. What is du? Well, what's du dx? We'll make it like that. What's the derivative of the left?
Natural log.
What's the derivative of the natural log of 5x?
Isn't it 1 over 5x?
Times 5. So it's 5 over 5x. Or 1 over x. In other words, it's the derivative of the outside, which is 1 over 5x, times the derivative of the inside, which is 5. And that reduces to that, oddly enough. So du is equal to dx over x. We're going to need du. Notice that we need du right there. What is dv? It's dx. It's everything else. It's everything that you didn't put with u. So what is v? Because we need a v also. If dv equals dx, then v equals x. Okay, so now this is going to be our answer. So what should I write? So the integral of natural log of 5x dx, which I didn't recognize as an integration by parts. That's why I looked it up in the table, and that's why I've never had to do that before, because that's not the correct way to do it. So this has got to be equal to u times v. What is u?
Natural log 5x.
What is v?
X.
Minus the integral, and this integral is an integral we should be able to do. What is v du?
X. dx over x.
Yes. What is that integral?
That would just be dx. Right?
Right? In other words, this is 1. If you took the integral of 1 dx, it's just x. What's the derivative of x? Right. That always has to be true. When you're integrating, whatever you get as an answer, if you differentiate that, that's got to be the original function you started with. So that's always a way for you to check whether your integration is correct, is by differentiating it, making sure you get what you started with. Okay, so this is our answer, and we need to evaluate it from 1 to 4. So let's do that. And you can't hardly use too much parentheses here. Just know that. So what's this term right here? Start with the bigger limit of integration.
Yeah.
So 4 natural log of 20, 4 times 5.
Okay, so it's 7 point.
Hold on, let's fill it out first. Before we start converting it to decimal, let's fill the whole thing out. So it's 4 natural log of 20 minus what?
4.
Okay. Minus what?
1 natural log 5 minus 1.
Okay. Now, and I think that's an important step. If you try to get ahead of yourself, you're just asking for trouble.
Yeah.
So let's do the left paren. What number is that? And again, they say do not round until the final answer. Boy, that is a strict criterion there. That's almost asking you to be able to understand your calculator's store function, which would be nice. Do you know how to use that? Do you use it?
No, I don't.
I don't either. But to get around not using that, just make each one of these to 6 decimal places, and then we can't get it wrong.
All right. 7.982929.
And the other one?
I got it. Point 60943
For a final answer of
7.3735. Rounded.
Did I write that correctly?
Yep.
I don't know. I'm not sure I disagree with their methods. I've thought about it a lot, and there is a certain something to be said for being perfectly accurate. In other words, real-life problems really do mean you have to get 20 out of 20 and not 19 out of 20 to get the right answer. You know what I'm saying? And this computer aspect here forces you to be perfect. Okay. Using Lipit, what are we going to let be U?
It's going to be polynomial.
Yeah. I mean, I haven't seen one like this, but I guess this is definitely a polynomial. This is kind of an exponential. No, that's a polynomial also. That's x plus 13 to the 1/3 power, which is a polynomial, not an exponential. So you really have two polynomials here. So Lipit isn't a cure-all. It's not a complete answer to what determines U or not U. And I actually have two calculus books, and one of them focuses on what to make U, and the other one focuses on what to make dV. And they say make dV something that integrates easily, and make U something that differentiates easily. Well, if I make this dV, I can actually integrate that pretty easily. Notice that the derivative of the inside is 1. So I don't have to worry about anything there. So I can integrate that. And I can differentiate x. So let's try making U equal x, making dV everything else. I'm going to rewrite it so that it's more ready for integration. Let's see if this works. I mean, you can't believe how complicated this gets. Integration by parts. There are some problems that require iterative steps, like you have to do 4 of these things in a row before you can get to the final answer. Truly. So if the integral of u dv is equal to u times v minus the integral of voodoo, then what is the next step? And differentiate the left, integrate the right.
To differentiate. I think the terms mixed up that x squared.
No.
One.
Okay, so that's the left. Now let's integrate the right. What's this exponent?
1/3.
4/3 divided by 4/3.
Or times 3/4.
Let's write it like that. And just to prove that, because this actually is a u substitution, but notice the derivative of u is 1. So we don't really care that it's that. So let's differentiate this to make sure that it's back to what we started with. How would you differentiate this? Take the derivative of the outside. How would you do that?
The derivative of 3/4.
Start with the exponent.
4/3. So
4/3 times 3/4 times x plus 13 to the 1/3 times the derivative of the inside. We have to apply the chain rule. It's just that the derivative of the inside is 1. So that cancels with that, and we have what we started with. This right here. This x plus 13 to the 1/3. Okay? So we integrated it properly. So now, what's our answer? What is this right here?
okay, so I'm going to write that out again.
Oh yeah, for sure. You not only need to write it out, but you need to have a lot of paper But one thing you'll find about these problems is you better be starting at the top of the page, otherwise you're going to run out of room.
Yeah. All right,
They're difficult to do online because I don't have enough room here to write it all.
Yeah.
So what is UV? Okay, X
times V.
times this whole thing. Right, okay, so let's write that 3/4 x plus 13 to the 4/3. Okay, what's next?
And then minus the integral of that whole thing dx.
du was dx, yes. Now, notice that we've made a lot of progress. We started with an integral that we didn't know how to integrate, and we now have it down to an integral that we do know how to integrate. So, this is an indefinite integral, so we're going to be adding a c. So I'm going to go ahead and start writing it. 3/4 x times x plus 13 to the 4/3. And now what is the next thing I want to do?
Take the integral of that.
Okay, what is that? What's the easiest first thing to do?
Take 3/4 out.
Okay, what do we have left over? What's the integral of this?
It's going to be x plus 13 to the 5/3.
Add 1.
No, excuse me. 7/3 divided by 7.
Divided by 7/3. Plus c. So there's our answer. Now we just have to figure out how to make sure we get it into the computer in the way they want. Okay. So the only thing I see that we have to do is that right there. So we want to multiply this by 3/7. So let's see if I can write it properly first. Minus 3/7 times this is 9/28, correct? 9/28, yes. Can 9/28 be reduced?
No.
No, I don't think so either. So I'm going with that, and I'm confident. Whoops, hold on. I got to get to a point where I can see both at the same time. 3/4 x times x plus 13 raised to the 4/3. They do not make it easy. Now, minus, this is 9/28 times x plus 13 raised to the 7/3 plus c. So if you were a betting man, would you bet we're going to get a correct answer?
I trust you, but the website, no.
These are tough. These are really tough. But I'm betting we're going to get a correct answer.
Wow, good work.
These are tough. You got to be so perfect You just cannot make any mistakes whatsoever. And if nothing else, it does teach you that. Just not sure how many students are going to get through that, having to be absolute perfectionists.
Yeah, no.
That's the thing. I mean, I'm a professional tutor and I can barely do it. Okay, let's see. The applications of integration are integration as net change. And that's what we're looking at here. They give us a rate of change formula. So if we want to figure out what the total change is after the sale of 14 calculators, we need to take the integral of this function and then answer it for 14 calculators. So, boy, their little hint is kind of helpful, I think, maybe, I don't know. So let's start out. We want the integral. Always know that if they give you a derivative function like that, then you want to take the integral of it at some point. Actually, it becomes this problem right here. Okay. We're going to almost certainly use integration by parts. How do I know that? Is because we have a polynomial function combined, multiplied by a transcendental function. Transcendental functions are log functions, trig functions, e to the x functions. Those are all transcendental functions. Inverse trig functions are transcendental functions. So whenever you have a... What's that?
They're all the awful ones is what you're saying.
Well, whenever you see that, think integration by parts, because at some point in time, like this problem here, they don't tell you to integrate it using integration by parts. And there are a lot of different integration methods. At this point, you've only learned 3 of them. Integration using the power rule, which only works for simple polynomials. Integration by substitution, which handles quite a few others. Integration by parts, between the 3 of them, they probably only handle 20% of the functions that you got to integrate. So there's a whole list of more techniques to come. And that's what makes integral calculus so hard. It's not at all easy like differential calculus is. So we know that this is probably an integral by parts problem, since that's what we've been doing. So what should I let u equal? Limit?
Natural log x plus 7.
Good. And how about dv?
It's going to be x plus 7 dx.
Correct. Remember, the primary formula is this. So we have to know all these things. We need u, which we know now. We don't know v yet, but we're going to integrate this thing on the right to get v. And we need du. So let's start by differentiating the left. It's the derivative of the natural log of x plus 7.
1 over x.
1 over x plus 7. That would be the derivative of the outside times the derivative of the inside, which is just 1. Okay? In other words, if this was a 2, then the answer would be 1 over 2x plus 7 times 2.
If what were 2? Say that again.
If I had a 2 in front of that x, like I've written, then the derivative would be 1 over 2x plus 7 times the derivative of the inside, which is 2. We don't have a 2, so let me not confuse the issue too much by writing 1 in there. But it's important to recognize that you do have to apply the chain rule to do this. So that makes du what? Since we need du, makes it 1 over, I can actually write this as dx over x plus 7. And this is what you're liable to encounter, so make sure you understand that's the same thing. And v is what? Now here's where they've given us a hint as to how to take the integral of that. Well, I don't really need to just apply the power rule to this. Notice why we can apply the power rule to this. It's because the derivative of the inside is 1. It's the only reason we can apply the power rule to this.
Okay.
So what is v? It's x plus 7 squared divided by 2 when we apply the power rule.
Oh, is it the whole thing because it's in parentheses?
Yeah, what the hell do they mean here? The antiderivative of x plus 7 is this. Well, okay, that's what I did.
I see. I did exactly what they said not to.
Make it x squared over 2 plus 7x. Well, notice that's not that. Oh, I see. X squared over 2 plus 7x. Yeah, you can't do that because it's in parentheses. Oh, interesting. Actually, I'm not sure I was aware of that. Yeah. Wow. What they're saying is the following. The integral of x plus 7 dx, how can that not be the same as the integral of x plus the integral of 7, which is x squared over 2 plus 7x? Well, if we take the derivative of this, what do we get? We get 2x over 2 plus 7, which is x plus 7. I don't think it matters. I think it's the same thing. Hold on. It simplifies matters to write it as this rather than this. They are the same thing. If we were to expand that and break it up into 3 partial fractions, we would get this. I'm quite sure. So their hint is more confusing than anything else. I'm not sure it simplifies things at all. It makes it harder to understand. Okay, so we're back to this. Okay, so now we have everything we need. So what is uv minus the integral of v du?
Okay, hold on. I like to write this one out for each problem.
Oh, for sure. I'm saying you may want to review this on the online recorded version just to help.
Yeah. Okay, so it's going to be natural log x plus 7, and then v.
I'm going to put absolute values around that because I remember we didn't do that once. Actually, that is the correct u, I believe. what is, okay, and then times v, which is x plus 7 squared over 2, like that. What's next?
Minus the integral of v times dx over x plus 7.
Okay. Plus c. Oh, no, this is an indefinite integral. We're evaluating this from 0 to 14.
So no c.
No c. Whenever you're doing definite integrals where you have limits of integration, you don't need the c because it gets canceled out. In other words, when you evaluate it at 14 minus its evaluation at 0, that's going to give you the total revenue in those 14 calculators. So let's see, we're not done yet here. Let's figure out what this integral is here. What's the next step?
We can cancel out one of the x plus 7s, right?
Yep. So we'll cancel out that and that exponent. And let's take the 1/2 out. So now we have this. Okay. So what's that equal to? What's the antiderivative of x plus 7?
Antiderivative, so x squared plus 7x.
No. Remember to use their...
Yeah,
well, actually, you're right. That is a correct answer, but they're suggesting that we'd be better off using their other representation of it. And it's important to make sure that you don't square that denominator. Notice it's only the numerator that's squared. Okay, so let's simplify. So we have, oh good, we're going to have to put a number here in anyway, so I don't think this absolute value matters. Minus 1/4 x plus 7 squared. Evaluated from 0 to 14. Now, you understand why we're evaluating this from 0 to 14? As opposed to just figuring out what it is at 14?
I think you forgot an x plus 7 squared over 2.
You're right. No, I multiplied the 2 by the 1/2 and made it 1/4.
I mean on the left side of the equation.
Oh boy, you're right. Okay. So, the reason we're doing it from 0 to 14 is because this is an integration as net change, which is basically we're taking the formula they gave us for r prime of x that looks like this maybe, and we're figuring out what the area under the curve is between 0 and 14. And this is going to be the total number of calculators produced, or rather the total amount of revenue for the first 14 calculators. It's another difficult concept to grasp, but that is an application of integration. So let's see, what do we have? We have natural log of 21 times 21 squared over 2.
Hold on, I'm sorry. Where'd you get 21?
I'm plugging in 14 for x. 14 plus 7.
Oh, I'm sorry. I thought it was 14 times 7.
No, 14 plus 7. Okay. Minus 1/4 of 21 squared. So that's the left part of our thing. So we need a number for that. Hold on. And then we're going to subtract the right part of our evaluation. And we need a number for that. So let's first of all write the right part out. We're going to take the top row and subtract the second row. So what's the second row? We're going to substitute 0 for x. So we have natural log of 7 times 7 squared over 2 minus 1/4 of 7 squared. So this row here, can you get me a number for that?
Yeah.
In other words, this first row here is evaluated at 14.
Alright, so natural log 21.
Make sure you don't square the 2. Only square the 21 and then divide that by 2.
Oh, yeah, okay. Double parentheses here.
I know it. It's brutal. This is as much a test of your ability to input it into the calculator as it is to solve the calculus part of it. And I needed 6 digits, or 6 decimal places. Oh, no. The final answer needs to be rounded to the nearest cent. Round all intermediate values to 2 decimal places. I can give it a go on Wolfram Alpha if you want.
Yeah, you might as well try while I'm doing it.
Okay. Oops. Don't need that anymore.
Okay, so I got 561 and change for the left sides.
Don't we need to know the change?
Yeah.
Okay.
Oh, so 561.0677.
That's all we need.
19.
It said round all intermediate values to 2 places. So that's 561.07. Right?
2 places wouldn't that be? Yeah.
Okay. And what about this quantity here?
Alright.
And again, make sure you don't round the 2 in the bottom of this fraction, just the 7. I mean, don't square the 2. Well, the problem with those graphing calculators is when you're done, they don't confirm that what you put in was what you wanted, which is the beauty of Wolfram Alpha. It does confirm that.
Mm-hmm. For the next side, I got 35.42. Yeah, it'd just be 0.42.
Let me read their instructions again. Round the final answer to the nearest cent, which is 2 decimal places. Round all intermediate values to 2 decimal places as needed. Okay. So what is the result of this? All right.
525.65.
Okay, so that should be our answer. I'm not as confident of this one.
Me either.
Just because there were so many calculations to be done. No, not because you did them, but because of the calculations are so complex. Let's first of all, before I enter that, is that a reasonable answer? Well, it's positive. Yeah, I would think that should be a reasonable answer.
Yeah, 7's a lot bigger than 0. So
Well, $525 for 14 calculators sounds like a reasonable answer. Beautiful. Sean, can you hold on 2 minutes? I got to run to the restroom.
Yes.
Okay, I'll be right back. All right. Sorry about that. I was thinking, I guess if you have to build a bridge that's not going to collapse, it does have to be perfect, doesn't it?
Mm-hmm.
All right. It's basically just an integration problem. They tell you how to do it. So what's our integral that we want to integrate, and from what? I mean, oh. What are our limits of integration?
Uh, 0 to 6.
Mm-hmm. Okay. Notice we have a polynomial. This thing's easy to integrate. No problem there. But this part here is what? It's a polynomial function times an exponential function. That's integration by parts. Okay.
So we need to find u first.
Yeah, I'm trying to figure out how we want to write this. I don't want to forget this part here. What's the integral of that?
Of the left side?
Yeah.
11.05 x
T in this case.
t.
Okay. So let's write it, make sure we don't forget it. And to integrate by parts, what's u?
172.1 t.
What's dv?
dv would be negative 11.05.
No. Notice that this plus sign means that when you take the integral of the sum, it's the same as the sum of the integrals. So this is the same as putting another integral sign in front of that plus sign. So we've already handled the minus 11.05 part of it.
Okay.
That's over here.
E
So
negative t over 1.2 dt.
okay, and we know we're going to need a du, and we know we're going to need a v. So let's start with the du.
du dt over would it be the e?
Well, what's du dt?
du dt.
Just that coefficient. Subtract 1 from this exponent, and it gets rid of the variable. So du dt is just that coefficient. Remember, we're differentiating the left side, which makes du equal to this number times dt. Okay? Now, what's v going to be equal to?
V is going to be...
Always start out with what you have.
E to the negative t over 1.2 squared.
No. No. Remember, the integral of e to the x is e to the x. You don't do anything more with the exponents. But the integral of e to the 2x is e to the 2x divided by the derivative of the top, which is 2. So you need to divide this answer by the derivative of the top. What's the derivative of the top?
The derivative of negative t over 1.2?
Yeah.
Would it be 1.2?
Well, it's 1 over 1.2. So it's divided by, put the negative sign there, 1 over 1.2. That's the coefficient of t. It's 1 over 1.2, or negative 1 over 1.2.
So there
So
are two negatives?
well, not really. One of those negatives goes with the exponent, the other one goes in front of the fraction. So here's what V really is. V is negative. I'm going to flip this and multiply. So I'm going to multiply by 1.2 e to the minus t over 1.2. Okay. And notice that you can do that. Even though it's a decimal, you can still flip it and multiply. Notice that 1.2 is 6/5. So that would be 5/6. So if I flip it and multiply, I'm multiplying by 6/5 again, which is 1.2. So, okay, so now I have a du and I have a v. So, using the integral by parts, remember I want uv minus the integral of voodoo. So let's substitute. What's u?
Okay, so we want first 11.05 t, right?
Ah, thank you. Negative.
Yes.
Let's kind of hold that aside, only because I don't have enough room to write it. So let's make sure we don't forget it. So I will write it, minus 11.05 t, but I don't want to write it and confuse myself with that. So let's keep these separate for the moment. So what is uv?
Okay. 172.1 t times v, excuse me. Minus the integral of that again be and du.
Oh, what is du?
172.
Are you kidding me? I don't even have enough room to write it on this. Let's see. No, that didn't help. I didn't think it was going to. Let's see. So it's du, and du is 172.1 dt. Well, there's the dt part of it. Let me put the 172.1 in front, like that. Okay? All right. Okay, so we have this. Let's take out the 1.2, multiply it by 172.1. What do you get?
Sorry, I missed that. What did you say?
We're going to remove this negative 1.2 outside the integral also, because it's a constant. We can do that.
Okay.
So let's multiply that by 172.1.
Okay. 172.1 times negative 1.2. Negative 206.52.
Notice that we had two negative signs, so it turned it positive.
Wait, where's that first name?
I combined the two negatives, this negative and this negative.
Oh, you're doing okay, I thought you were doing that from the left side.
No, there's so many things we have to keep track of here that it'll be amazing if we get this right. Okay, and let's see. What is the integral of that?
to 1 over...
Okay? Whenever you're integrating an exponential function, remember this is not a polynomial function. This is an exponential function. It's a transcendental function. The integral of e to the x is e to the x. It's not e to the x squared or anything like that. So the integral of this is going to be whatever we're looking at divided by the derivative of the exponent. Like that. Okay? So, let's see if we're ready to evaluate this sucker yet. Let's see.
dt also, right?
No, I integrated it. So once you integrate it, you get rid of the dt. So starting from the beginning, we have minus 11.05t, which was the integral of the first part. Oh, thank goodness it's a plus. Okay, everything's plus here. We don't have any negative signs anymore. So the first part is this part here. And so we do know what that is. That is 206.52, and it is negative. It's negative because of this negative sign right there. Times e to the minus t over 1.2. And then plus 206.52 times, are you kidding me? E to the minus t over 1.2 divided by minus 1 over 1.2, which is the same as multiplying it by minus 1.2. So that's a negative 1.2 times that. So there's our expression that we have to evaluate from 0 to 6. Let me erase here the stuff that doesn't belong. What college do you go to, Sean?
CU Boulder.
Ah, and you're going to Boulder, or are you going to Denver? You're going to Boulder.
Boulder.
Because my student today was CU Denver, and he wasn't using mathxl.com, but he was using something very, very similar to this.
Well, if you get a boy named Rory or a girl named Kelsey that go to CU Boulder doing this exact stuff, they're in the same class.
Okay. All right. I can't help but think that this is a misstep in education. It's a good thought, having computers be able to give people math tests, but they need some tweaking.
They need to account for a small error.
Well, not just that. I mean, notice what we're doing. We're spending all of our time on algebra.
Yeah.
What we should be doing is setting up the integral and then going to the next problem. This has turned this calculus course into a college algebra course, or really a college arithmetic course. It's your ability to come up with the precise number to evaluate these things. All right, let's do it. You'll notice the second part of the evaluation where we have to substitute 0 will be quite easy. It'll make most of these things go to 1. Most of these exponential functions will go to 1. So let's start with evaluating it at 6.
Okay.
Makes this 66.3.
I'm just going to write the whole thing out because it's easier.
Well, I agree. And in fact, let me write it all out so that we... So what is 6 over 1.2? 5. At least they gave us that luxury. What is 1.2 times this 206.52?
$247.824.
E to the minus 5 also. So that's the left side. I guess we need to come up with numbers here for the left quantity. You know how to do these e to the minus 5? That's just 206.52 divided by e to the 5th. Let's see. If you want to give me intermediate numbers here, I can write them in.
Got it.
Okay.
Actually, I'm going to give you the intermediate.
Okay. What's this one?
Okay, so the negative 206.52 e to the negative 5th is negative 1.315.
And this one over here?
Oh, it's negative 1.3915.
Is that correct?
No, that one was for the left.
Okay. I didn't...
I haven't done it right yet.
So this is 3915, okay. This should be a little bit bigger. Hair.
And then I actually multiplied that by negative 66.3.
You don't want to do that. You don't want to do that. I already multiplied this by the 6.
Okay, so then now the negative 247.824 e to the negative 5th. That equals negative 1.670.
Okay, so we have negative 66.3 minus that minus that.
Write that out too.
Mm-hmm. Should be 63 and change, or 62 and change, maybe. Negative. No, excuse me, it should be negative 69 and change.
Yep, negative 69.3615.
That's the evaluation at 6. Now let's evaluate it at 0. I'm going to erase everything here. Okay, this term becomes 0. This term becomes 20652, because when you substitute 0 for t, e to the 0th power becomes 1. What was this number again? 1.2 times 206.52?
247.824.
Okay. So these two combined become a negative what? 454.344?
Yep.
Notice we're subtracting a negative. So take this negative 69 and change and add 454.344 to it.
Sorry, write the whole thing out.
It's okay.
$523.7.
I don't think so. This is a positive 454, and we're subtracting 69.
Oops, I didn't put a negative in front of that. Let's do 454.344.
Yeah, just subtract.
69.
There you go.
0.3615. 384.9825.
That's supposed to be our answer, huh? I mean, we've done all the steps. Whoops. Hold on. And let's make sure that everything's in kJ here. kJ per hour. All right, let's go for it. I don't know. I don't even want to begin to think. Round to the nearest whole number, 385. Right?
Maybe it's just off. Try like 386.
How many chances do we get?
3 probably.
This is exactly what we did. We first used the sum rule to separate out the minus 11.05, and then we integrated the rest of it using integration by parts. Finally used the indefinite integrals to find the definite integral. We did that going from 0 to 6.
Maybe you just do 384. I don't know, there's so much small numbers.
There is. It's just, it's almost, I'm not sure it is either. That's why I'm really kind of getting upset with this software. Because by the time you've done the 20 minutes of calculations and you don't come up with the precise answer, how do you figure out where you made your mistake? It's not really going to help me solve this. We know how to solve it.
Yeah. I don't know, you can try the
I'll try
4.
I'll try 4, but I suspect that somewhere one of us made an error. 172, huh? Notice, no, 172 is not just half of that or anything. I don't know. I don't know what to tell you. Next time, if you want to pick up with this problem, and we'll do a similar problem and go through the algebra again, that's fine. I don't know.
Yeah.
Boy, I'd like to talk to you. I'd like to talk to your teachers. What I'd like to do, just to give them my feedback on this software that they're using.
Yeah.
It's something very new, and it's something they're going to have to take a second look at, because they're really not doing you any favors by having this be the technique instead of having a teacher give you tests that she grades or he grades, where they can tell that your technique was correct, you just got the arithmetic wrong. And software
this is an online class.
Yeah, I know. Trust me, I'm not doubting the future of online education. I think that that's where we're headed for good. But they got to figure out how to get around the problems that this particular software presents, which it becomes not a test of calculus, but a test of algebra and arithmetic.
Mm-hmm.
And that's what the feedback I would like to give your teacher. Or maybe you could tell them that I think that, and see what they think. You do have a physical teacher, right, or not?
Yeah, but I never met him.
You never met him or talked to them? Wow. Yeah, well, I don't know what to say. It's really sad because it doesn't need to be like this. They don't need to use numbers like this. They could put in a very simple function here to determine whether or not you get the concept. And that's what's important. That's what most calculus classes do, is they give you the concept with simple numbers so that the integration is easy enough. Instead of this garbage with all the decimals and the complicated exponents. And I mean, it's not garbage. You need to know integration by parts, but you don't need these kind of numbers to learn it.
Mm-hmm.
So I don't know. Let's end it for now. And
I was also wondering,
mm-hmm.
instead of next Tuesday, are you available on Sunday at all?
Yeah, let me look here. This Sunday, yes, I am.
Okay.
What time? I got the whole day.
Probably like 11 to 12:30.
Yeah, that works. Let me put it in there.
Okay.
Hold on. Boy.
And then we owe you for last week and this week. I believe it's 4 sessions.
Yeah, that's
Okay,
correct.
and we'll have that tomorrow. We just have to wait for payday.
Yeah, that's fine, Sean. 11 to 12:30, right? Sunday.
Yes.
Okay. All right. Sounds good. And then no session next Tuesday, is that right?
Correct.
On the 30th. Okay. Let me cancel this one. For this one only. All right. I will talk to you Sunday.
All right. Thank you.
All right, Sean. Bye-bye.
Bye.